There are lots of different concepts you can talk about when you talk about AI, and they've been around for a very long time. So things like machine learning is the ability for machines to learn from when they've done things. It's exactly the same as a child learning something new. Now, we used to think that computers couldn't do this, but actually with machine learning, we've learned through algorithms and all these other things, they start to and they can do. This does not mean they're sentient, it just means the machines are learning something new, which is awesome. You look at something like a large language model, and even though the term LLM seems a bit weird and out there, it's as simple as you take an awful lot of data and you have a model, and that model can then produce a result. And if you use machine learning on top of that, you get this idea called AI. Again, it doesn't just need that. There are other ingredients as well, like natural language processing. And natural language processing is the ability for the machine to start to use language as a human being would. This does not mean that they are sentient in any way, but they can start to mimic our own intelligence, and that's why it's exciting. They can start to somehow act a little bit more like us. I wouldn't always get bogged down with the terminology. It's a little bit like wondering what electricity is. Sometimes you've got to think, actually, I just want a nice piece of toast and use a toaster. I wouldn't get too bogged down with how electricity works.
The challenge with artificial intelligence right now is the education and everybody understanding what the different services do and solutions and what they mean. It's a vast field. There's huge amounts of different acronyms and technologies in play. But if we simplify it to machine learning, deep learning, and large language models, that's probably a great place to start. If we think to machine learning is really, in my opinion, it's like a super calculator. It's like the best Excel spreadsheet ever. It reads data, it predicts, it analyzes, and it categorizes data. That's the best way to look at machine learning. It's not actually that new. It's been around for many years, and many organizations have been using it to do exactly that, to assess data sets and to formulate decisions. If we look to deep learning, this is the progression. This is where AI began to become more useful. This is where, instead of it being like a great big calculator or a great big Excel spreadsheet, deep learning works similar to the human brain in a neural network. So it starts to work through things in a particular order. Best description I can give between machine learning and deep learning is if we were to ask a machine learning database to tell us if an image was a picture of a cat, a dog, or a bird, it would go through that based on some instructions that we give it. So we'd say cats have whiskers and pointy ears, birds have beaks, and dogs have floppy ears and wet noses, for example. The machine learning would go through that in order. So it would say, does this image have whiskers? Yes, it might be a cat. Does it have pointy ears? It's highly likely it's a cat. But it would categorize those. Deep learning would immediately look at those images and start to work out for itself, similar to our brain, whether those images immediately have those characteristics, and then it would assume, based on that it's a cat, a dog, or a bird. That progression is really where we started to see artificial intelligence become super useful. If we then bring in large language models, this is where we take the concept even further. So you can imagine a vast database of information, and it's suggested that most large language models are 17 times the size of the British Library. So huge amounts of data. And if you were to put a transformer, something called a transformer, which was invented by Google around 2017, I believe, into that has a generative model that can actually start to work with that data set. So another example, similar to the cats and dogs, is you might ask a large language model to finish a sentence. So you could say, it's raining cats and the transformer would then say, well, what could it be? What could the next word? So it predicts the next word. So it would look at these vast data sets, and instead of looking for pictures of a cat, dog, or a bird, it would say, what do we think the next word in this sequence is? And it would say, raining cats and dogs.
Large language model, LLM, is an important one to understand. That is the technology that basically finds paths through data, and as these large language models get better, they find better, more accurate paths through the data. So for example, OpenAI has GPT. So it has GPT-3, GPT-4, they've just released GPT-4o, there'll be GPT-5 coming soon, no doubt, and it's basically ever better ways of finding paths through the data to create more accurate, more detailed responses.
It's been one of my biggest challenges because language is a huge gatekeeping element of getting into any subject, whether it's to look for the right solution to buy or the right consultant to bring on board or the right training course to find. And some of those basic terms, large language models, all that's describing is what it says in the tin. In effect, it's something that's been trained on a large part of the content that can be scraped from the internet or obtained through other means to then interpret language in a way that allows you to interact with it and get some kind of natural output. I'm not going to give you a list of terms now. What I'm going to recommend is that people find non-profit bodies that they can volunteer with, hang around with, and learn the language in context. Or go onto ChatGPT or Claude or Llama, because I use it for that. When I see someone who perhaps tweets out or does a LinkedIn post where every seventh word is something that I don't understand, I just fire it straight into a language model and get some output.
What I would say is what I do know about it is it's full of biases. So because it's programmed and designed by humans, humans will input their biases. And unfortunately, unlike humans where we might recognize what our bias is, AI is not very good at recognizing there's a bias system in. So for example, if I'm using AI to kind of screen people for, recruiting for a new CEO of a company, what the AI system would do would look at previous trends and probably conclude that most CEOs are male. Yeah, I've had 200 applications in, I've got 100 male and 100 female. What it would do is it will make that algorithmic decision, in past experience, it's been male. So actually, what I'll put forward are 9 males and 1 female, because that fits the model of what I've been programmed to look at.
I think, by and large, we should stay away from most of the jargon. I think understanding the foundations of how this is working, and an LLM, a large language model, is really interesting for that. Because what it's really telling you is that there's no creative intelligence going on here. What we've done is we've taken a computer and trained it on the history of human output, whether that is 10 million press releases or 10 million pop songs or 10 million Hollywood movies, and given it a set of patterns that it can then recreate. And so, so much of current AI is not about creativity, it's about replication. It's about understanding a pattern and then doing something that looks a bit like that pattern. And that's what LLMs allow you to do. They allow you to take this huge amount of training data, train a machine to recognize patterns, and then replicate those patterns in ways that are useful.
I would go back to my key thing with anybody is think about why. Why do you want to know? So for some people, you need to be aware from a security point of view. So if you're using ChatGPT, for example, to work up a new product, are you aware that everything you type into ChatGPT is open source? So unless you have some brilliant piece of code in place, which if you're uninitiated, I'm assuming you don't, then everything you've just typed in is now available to be spurted out to anybody else. So anybody that's had those awful experiences of where Alexa has recorded a conversation and played it back to your neighbours down the road, happened to a friend of mine. AI can use your content, and we all know our phones listen to us and then advertise to us based on what it's hearing. So AI is doing that all the time. So security is one thing to be aware of. The other is where you might use it. And I think as we go into the future, we'll see Internet of Things particularly being used in all sorts of places. So and Internet of Things, for people that don't know, is the idea that you can put tiny chips that sort of both send and receive into inanimate objects. So your plant can tell you when it needs water. In fact, it doesn't even need to tell you. It will just tell the sensor that turns on the water and feeds it some water. So your plants get watered.
As businesses, it's often said, an organisation's greatest asset is its people. But I don't think it is its people anymore. I think an organisation's greatest asset is how its people use technology. And that's the difference. That's the intersection between where technology and things like AI can make a difference with your people, or it can make a difference with somebody else's people. And I think as organisations, that's where we need to understand that every business is now a technology business.